Finals in Discrete Structure 2, May 15, 2024. Hi everyone! Hi Prof. Doc Alagos. Now, I'm going to present about Binomial Theorem, Pascal's Triangle, and Combinations, presented by me, Herby G. Estrella, BSCS, 3 Old Mode, 3rd Year, 3rd Term, 2023-2024. Binomial Theorem. The Binomial Theorem provides an efficient method for expanding binomial expressions and finding coefficients in the expansion. It has applications in various fields such as calculus, probability, and combinatorics. It states that for any non-negative integer n, the expansion of open parenthesis a plus b close parenthesis power of n can be expressed as the sum of terms of the form c n chooses k times a raises open parenthesis n minus k close parenthesis times b raised to k, where c n chooses k represents the binomial coefficient or combination of choosing k elements from n. The binomial theorem states that open parenthesis a plus b close parenthesis power of n equals to sum k equals 0 to n binomial n chooses k times a raises to open parenthesis n minus k close parenthesis times b raised to k. The binomial coefficient for each term are calculated using the formula binomial n chooses k equals to n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark, where binomial n chooses k, it is the binomial coefficient of each term representing the number of ways to choose k elements from a set of n elements. A and b are both constants or variables. N is a non-negative integer. First, let's answer example number 1. Expand the given example, open parenthesis 3x minus 2y close parenthesis to the power of 2. Use the formula of binomial theorem and binomial coefficient. We start by applying the binomial theorem, which states that for any real numbers a and b and any non-negative integer n, the expansion of open parenthesis a plus b close parenthesis to the power of n can be expressed as a sum of terms. This allows us to expand expressions involving binomials efficiently. Identifying the terms, the expansion of open parenthesis 3x minus 2y close parenthesis to the power of 2 consists of 3 terms, term 1, term 2, and term 3. Calculating each term. For each term, determine the binomial coefficient using the formula binomial chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. In term 1, using the binomial coefficient formula, we find that binomial 2 chooses 0 equals 1. The powers of 3x and negative 2y are 2 and 0 respectively. Multiplying these together, we get 9x raised to 2. Term 2 is the binomial coefficient binomial 2 chooses 1 equals 2. The powers of 3x and negative 2y are 1 each. Multiplying these together, we get negative 12xy. Term 3, the binomial coefficient binomial 2 chooses 2 equals 1. The powers of 3x and negative 2y are 0 and 2 respectively. Multiplying these together, we get 4y raised to 2. Combining the terms, let's combine the terms. Finally, we combine all the terms to get the expanded expression open parenthesis 3x minus 2y close parenthesis raised to 2 equals to 9x raised to 2 minus 12xy plus 4y raised to 2. Now let's answer the example number 2. Expand the given example. Open parenthesis a plus 2b close parenthesis raised to 3. Use the formula of binomial theorem and binomial coefficient. We start by applying the binomial theorem, which allow us to expand expressions involving binomials efficiently. Identifying the terms, the expansion of open parenthesis a plus 2b, close parenthesis raised to 3 consists of 4 terms. Term 1, term 2, term 3, term 4. Calculating each term. For each term, determine the binomial coefficient using the formula binomial n chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. Term 1 is, using the binomial coefficient formula, we find that binomial 3 chooses 0 equals 1. The powers of a and 2b are 3 and 0 respectively. Multiplying these together, we get a raised to 3. Term 2 is, the binomial coefficient binomial 3 chooses 1 equals 3. The powers of a and 2b are 2 and 1 respectively. Multiplying these together, we get 6a raised to 2 and b. Term 3 is, the binomial coefficient binomial 3 chooses 2 equals 3. The powers of a and 2b are 1 and 2 respectively. Multiplying these together, we get 12ab raised to 2. Term 4 is, the binomial coefficient binomial 3 chooses 3 equals 1. The powers of a and 2b are 0 and 3 respectively. Multiplying this together, we get 8b raised to 3. Combining the terms, finally, we combine all the terms to get the expanded expression open parenthesis a plus 2b close parenthesis raised to 3 equals a raised to 3 plus 6a raised to 2b plus 12ab raised to 2 plus 8b raised to 3. Next is example number 3. Expand the given example. Open parenthesis a plus b close parenthesis raised to 4. Use the formula of binomial theorem and binomial coefficient. We apply the binomial theorem to expand the expression efficiently, identifying the terms. The expansion of open parenthesis a plus b close parenthesis raised to 4 consists of 5 terms. Term 1, term 2, term 3, term 4, and term 5. Calculating each term. For each term, determine the binomial theorem using the formula binomial n chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. For term 1 is, using the binomial coefficient formula, we find binomial n chooses 0 equals 1. The powers of a and b are 4 and 0 respectively. Multiplying these together, we get a raised to 4. Term 2 is, the binomial coefficient binomial 4 chooses 0 equals 4. The powers of a and b are 3 and 1 respectively. Multiplying these together, we get 4a raised to 3b. Term 3 is, the binomial coefficient binomial 4 chooses 2 equals 6. The powers of a and b are 2 each. Multiplying these together, we get 6a raised to 2, b raised to 2. Term 4 is, the binomial coefficient 4 chooses 3 equals 4. The powers of a and b are 1 and 3 respectively. Multiplying these together, we get 4ab raised to 3. Term 5 is, the binomial coefficient binomial 4 chooses 4 equals 1. The powers of a and b are 0 and 4 respectively. Multiplying these together, we get b raised to 4. Combining the terms, finally, we combine all the terms to get the expanded expression open parenthesis a plus b close parenthesis raised to 4 equals to a raised to 4 plus 4a raised to 3 b plus 6a raised to 2 b raised to 2 plus 4ab raised to 3 plus b raised to 4. Next is Pascal's triangle. It is a triangular arrangement of numbers where each number is the sum of the two numbers directly above it. It is named after the French mathematician Blaise Pascal, who introduced it in the 17th century. Pascal's triangle provides a visual representation of binomial coefficients and offers a convenient way to expand binomial expression using the binomial theorem. It exhibits various patterns and symmetries, making it useful tool in combinatorics and algebra. Pascal's triangle is constructed as follows. The first row contains just the number 1. Each subsequent row begins and ends with 1. To fill in the interior numbers of each row, add the two numbers directly above it. Example number 1 is, construct the Pascal's triangle for the first 7 rows. The Pascal triangle is constructed by starting with the row containing the number 1. Each subsequent row begins and ends with 1. To To fill the interior numbers of each row, add the two numbers directly above it, identifying the terms. The expansion of open parenthesis x plus y close parenthesis raised to 6 includes 7 terms: term 1, term 2, term 3, term 4, term 5, term 6, and term 7. Calculating each term for each term determines the binomial coefficient using the formula binomial n chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. Term 1 is, using the binomial coefficient formula, we find the Pascal triangle binomial 6 chooses 0 equals 1. The powers of x and y are 6 and 0 respectively. Multiplying this, we get x raised to 6. Term 2 is, the binomial coefficient Pascal's triangle binomial 6 chooses 1 equals 6. The powers of x and y are 5 and 1 respectively. Multiplying this, we get 6x raised to 5. Term 3 is, the binomial coefficient Pascal's triangle binomial 6 chooses 2 equals 15. The powers of x and y are 4 and 2 respectively. Multiplying this, we get 15x raised to 4, y raised to 2. Term 4 is, the binomial coefficient Pascal's triangle binomial 6 chooses 3 equals to 20. The powers of x and y are 3 and 3 respectively. Multiplying this, we get 20x raised to 3, y raised to 3. Term 5 is, the binomial coefficient Pascal's triangle binomial 6 chooses 4 equals 15. The powers of x and y are 2 and 4 respectively. Multiplying this, we get 15x raised to 2, y raised to 4. Term 6 is, the binomial coefficient Pascal's triangle binomial 6 chooses 5 equals 6. The powers of x and y are 1 and 5 respectively. Multiplying this, we get 6x, y raised to 5. Term 7 is, the binomial coefficient Pascal's triangle binomial 6 chooses 6 equals 1. The powers of x and y are 0 and 6 respectively. Multiplying this, we get y raised to 6. Combining all terms, we get the expanded expression open parenthesis x plus y close parenthesis raised to 6 equals to x raised to 6 plus 6x raised to 5y plus 15x raised to 4 y raised to 2 plus 20x raised to 3 y raised to 3 plus 15x raised to 2 y raised to 4 plus 6xy raised to 5 plus y raised to 6. Example number 2 is, construct the Pascal's triangle for the first 8 rows. The Pascal's triangle is constructed by starting with a row containing only the number 1. Each subsequent row begins and ends with 1. To fill in the interior numbers of each row, add the two numbers directly above it. Expand open parenthesis x plus y close parenthesis raised to 7 using the binomial theorem. The binomial theorem states open parenthesis a plus b close parenthesis n equals sum from k equals 0 to n binomial n chooses k times a raises to open parenthesis n minus k close parenthesis times b raised to k. Identifying the terms. The expansion of open parenthesis x plus y close parenthesis raised to 7 includes 8 terms: term 1, term 2, term 3, term 4, term 5, term 6, term 7, and term 8. Calculating each term. For each term, determine the binomial coefficient using the formula binomial n chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. Term 1 is, using the binomial coefficient formula, we find Pascal's triangle binomial 7 chooses 0 equals 1. The powers of x and y are 7 and 0 respectively. Multiplying this, we get x raised to 7. Term 2 is, the binomial coefficient Pascal's triangle binomial 7 chooses 1 equals 7. The powers of x and y are 6 and 1 respectively. Multiplying this, we get 7x raised to 6y. Term 3 is, the binomial coefficient Pascal's triangle binomial 7 chooses 2 equals 21. The powers of x and y are 5 and 2 respectively. Multiplying this, we get 21x raised to 5, y raised to 2. Term 4 is the binomial coefficient. Pascal's triangle binomial 7 chooses 3 equals 35. The powers of x and y are 4 and 3 respectively. Multiplying this, we get 35x raised to 4, y raised to 3. Term 5 is the binomial coefficient. Pascal's triangle binomial 7 chooses 4 equals 35. The powers of x and y are 3 and 4 respectively. Multiplying this, we get 35x raised to 3, y raised to 4. Term 6 is the binomial coefficient. Pascal's triangle binomial 7 chooses 5 equals 21. The powers of x and y are 2 and 5 respectively. Multiplying this, we get 21x raised to 2, y raised to 5. Term 7 is the binomial coefficient. Pascal's triangle binomial 7 chooses 6 equals 7. The powers of x and y are 1 and 6 respectively. Multiplying this, we get 7xy raised to 6. Term 8 is the binomial coefficient. Pascal's triangle binomial 7 chooses 7 equals 1. The powers of x and y are 0 and 7 respectively. Multiplying this, we get y raised to 7. Combining the terms. Combining all terms, we get the expanded expression, open parenthesis x plus y, close parenthesis, raised to 7. X raised to 7 plus 7x raised to 6 plus 21x raised to 5, y raised to 2 plus 35x raised to 4, y raised to 3. 35x raised to 3, y raised to 4 plus 21x raised to 2, y raised to 5 plus 7xy raised to 6 plus y raised to 7. Example number 3 is construct the Pascal's triangle for the first 10 rows. Pascal's triangle is constructed by starting with a row containing only the number 1. Each subsequent rows begins and ends with 1. To fill in the interior numbers of each row, add the 2 numbers directly above it. Expand, open parenthesis x plus y, close parenthesis, raised to 9, using the binomial theorem. The binomial theorem states, open parenthesis a plus b, close parenthesis, raised to n equals sum from k equals 0 to n binomial n chooses k times a raised to n, open parenthesis n minus k, close parenthesis times b raised to k. Identifying the terms, the expansion of open parenthesis x plus y, close parenthesis, raised to 9 includes 10 terms. Term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, and term 10. Calculating each term. For each term, determine the binomial effect using the formula binomial n chooses k equals n exclamation mark divided by k exclamation mark, open parenthesis n minus k, close parenthesis, exclamation mark. For term 1, using the binomial coefficient formula, we find Pascal's triangle binomial n chooses 0 equals 1. The powers of x and y are 9 and 0 respectively. Multiplying this, we get x raised to 9. Term 2 is the binomial coefficient. Pascal's triangle binomial 9 chooses 1 equals 9. The powers of x and y are 8 and 1 respectively. Multiplying this, we get 9x raised to 8y. Term 3 is the binomial coefficient. Pascal's triangle binomial 9 chooses 2 equals 36. The powers of x and y are 7 and 2 respectively. Multiplying this, we get 36x raised to 7, y raised to 2. Term 4 is the binomial coefficient. Pascal's triangle binomial n chooses 3 equals 84. The powers of x and y are 6 and 3 respectively. Multiplying this, we get 84x raised to 6, y raised to 3. Term 5 is the binomial coefficient. Pascal's triangle binomial 9 chooses 4 equals 126. The powers of x and y are 5 and 4 respectively. Multiplying this, we get 126x raised to 5, y raised to 4. Term 6 is the binomial coefficient. Pascal's triangle binomial 9 chooses 5 equals 126. The powers of x and y are 4 and 5 respectively. Multiplying this, we get 126x raised to 4, y raised to 5. Term 7 is the binomial coefficient is Pascal's triangle binomial 9 chooses 6 equals 84. The powers of x and y are 3 and 6 respectively. Multiplying this, we get 84x raised to 3, y raised to 6. Term 8 is the binomial coefficient. Pascal's triangle binomial n chooses 7 equals 36. The powers of x and y are 2 and 7 respectively. Multiplying this, we get 3x raised to 2, y raised to 7. Term 9 is the binomial coefficient Pascal's triangle binomial 9 chooses 8 equals 9. The powers of x and y are 1 and 8 respectively. Multiplying this, we get 9xy raised to 8. Term 10 is the binomial coefficient Pascal's triangle binomial 9 chooses 9 equals 1. The powers of x and y are 0 and 9 respectively. Multiplying this, we get y raised to 9. The final expression is combining all the terms, we get the expanded expression open parenthesis x plus y close parenthesis raised to 9 equals x raised to 9 plus 9x raised to 8 y plus 36x raised to 7, y raised to 2 plus 84x raised to 8, y raised to 3 plus 126x raised to 5, y raised to 4 plus 126x raised to 4, y raised to 5 plus 84 x raised to 3, y raised to 6 plus 36 x raised to 2, y raised to 7 plus 9x y raised to 8 plus y raised to 9. The next lesson is the combinations. These are fundamental concepts in combinatorics that deal with selecting subsets from a larger set where the order of selection doesn't matter, unlike permutations where the order does matters. Combinations focus on the composition of subsets rather than the arrangement of elements within those subsets. Combinations play a crucial role in various fields such as probability, statistics, and computer science. Understanding combinations is essential for solving problems involving selection, arrangement, and allocation of elements in a set or group. The formula for combination is C or combination n chooses k equals n exclamation mark divided by k exclamation mark open parenthesis n minus k close parenthesis exclamation mark. For n exclamation it denotes the factorial of n, k exclamation mark it denotes the factorial k open parenthesis n minus k close parenthesis exclamation mark it denotes the factorial of n minus k. Example number 1 is how many different 3-letter combination can be made from the letters A, B, C, D, and E. Combination of 5 chooses 3 or combination of 5 letters and 3-letter combinations. Use the combination formula and substitute it. 5 exclamation mark divided by 3 exclamation mark open parenthesis 5 minus 3 close parenthesis exclamation mark equals to 5 times 4 times 3 divided by 3 times 2 times 1 equals to 10. So there are 10 different 3-letter combinations that can be made from the letters A, B, C, D, and E. Example number 2 is a group of 8 students is to be divided into 2 committees of equal size. How many ways can this be done? Combination of 8 chooses 4 or combination of 8 students and 8 divided by 2 equals 4 committee of equal sizes combinations. Use the combination formula and substitute it. 8 exclamation mark divided by 4 exclamation mark open parenthesis 8 minus 4 close parenthesis exclamation mark equals to 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1 equals to 70. There are 70 ways to divide a group of 8 students into 2 committees of equal size. Example number 3 is how many ways can a committee of 4 members be selected from a group of 10 people? Combination of 10 chooses 4 or combination of group of 10 people and 4 committee members combinations. Use the combination formula and substitute it. 10 exclamation mark divided by 4 exclamation mark open parenthesis 10 minus 4 close parenthesis exclamation mark equals to 10 times 9 times 8 times 7 divided by 4 times 3 times 2 times 1 equals to 210. So there are 210 different combinations of selecting 4 members from a group of 10 people to form a committee. Thank you for watching. Please comment down below what are more questions. Submitted to Prof. Doc Alagos. Thank you for watching.